Hi, everyone. Thanks to Vikram for suggesting I can record a short intro for your panel. My experience in large-scale datasets is related to the Epic Kitchens dataset that we collected and annotated and released in 2 versions in 2018 and then extended in 2020. When we wanted to collect the dataset, we really asked ourselves, do we really need to collect another dataset? And there wasn't a large enough dataset in egocentric or wearable cameras. But still, we didn't want to fall into a trap that many others have fell into. And let me detail. So many people say, I need a dataset because I'm working on, say, object recognition. So they then go and try to collect a dataset that they can train and evaluate their methods on. And by doing that, the researchers who collect the dataset make a lot of decisions, like what classes they want to collect, how many examples per class, where to get these examples from. Once they collect the dataset, which they have thought carefully about, then this dataset becomes available, we can train models, and we can monitor the error of this dataset over time. And this continues to be the main dataset or one of the main datasets in the area of object recognition until a new, bigger dataset comes, which exposes some of the biases collected in the first dataset because the numbers are not exactly the same. There is actually, the most of the computer vision research is with this in mind. You decide the problem, and then you decide what datasets to collect. That makes datasets methods overfit to the dataset and makes them useful for the prime task for which the researchers have collected the data, and it's biased by the choices they made, mostly making it unnaturally balanced because of the machine learning background that assumes a balanced dataset. So it's unrelated to priors outside the dataset itself. There is one exception to this trend, and that's the Kitty dataset. So the Kitty dataset benchmark started with putting cameras, go around, record what you can with all the sensors you have. And then after that, define a series of potential problems this dataset can be trained on or can be evaluated on. Inspired by this, we also wanted to first collect our data and then think of the problems the dataset can be suitable for. So we gave people cameras and we said, record everything you can in your kitchens for 3 days, collecting or releasing 100 hours. This year, we have 5 different challenges on the same dataset between recognition, anticipation, detection, retrieval, and domain adaptation to new kitchens. But importantly, other researchers have used our dataset for other problems. There is a very recent work from Oxford on SLAM on doing a localization on Epic Kitchens, because we collected the dataset without really having a specific problem in mind. And in fact, we have been involved in another extension inspired by Epic Kitchens, give people cameras and let them record. And in our Epic workshop today on the 20th of June, Kristen Grumman is actually talking about the Ego4D dataset in our Epic workshop. So the dataset is basically extending the scope of let's collect data without really thinking of a particular task. And then let's see a series of tasks this data can be evaluated on. And we hope towards the end of the year to release 6,000 hours of egocentric videos collected by a consortium of 12 universities. So we can scale, but I believe there is a limit to how much we can scale what we call the training dataset, labeled or unlabeled. In my opinion, we really can't control these training sets. We need very good test sets, but the training sets are going to continue to expand and become, and currently we use them in the sort of pre-training, but they're very difficult to control. The problem with this proposal is that the comparison is unfair, because if you train on a bigger data set or a different data set, then you can't really say the 2 models are exactly comparable, even if you report their performance on the same test set. So last year, we introduced this notion, we call it the Supervision Level Scale, or SLS, and I'd be very keen to hear the panel's feedback on that. So as we said, methods are not directly comparable anymore, we believe, on the same test set because they use different pre-training. The amount of pre-training that now goes into the data sets is humongous. They use different types of data, often adding some additional self-supervision losses as they train the data itself, not only in pre-training. And of course, at the moment, we talk about few-shot or long-tail or zero-shot datasets or evaluation as completely different, as if they are different training sets, even though we just take a subset of these training sets. Actually, leaderboards are really currently hard to decipher, and we spend a good amount of our experiment section stating why our method is not comparable to method X, because they use bigger pre-training or more labels. Our proposal is for methods to self-declare what type of supervision they had used, but evaluate on the same test set. So we understand the impact of these different things rather than say we're not comparable to these other methods because they use different pre-training. So we propose some axes of this supervision scale. One of them we know to be pre-training, whether you start from random initialization or maybe ImageNet initialization, or you go all the way to using a proprietary private label test set that no one has access to. So you're not exactly comparable, but we know their performance on the same test set. Another axis might be how much training labels you use. You might have used weak supervision. You might have used full supervision or maybe additional labels you've labeled on the dataset. And of course, how much training data, which is different. So you can use full supervision, but few-shot learning. So few-shot learning, or what we call efficient learning, which is a subset of the training set, or all the way to using a train and a val split and additional data. By acknowledging that there are all different supervision scales, then we can put methods on some sort of a cube where 0, 0, 0, or the center, is methods that have the least amount of supervision. And then the other extreme is methods who have the most amount of supervision. And we can acknowledge that on a certain axis, what's the impact of this particular axis, in this case, the pre-training axis. And in this report, which we published last year, we actually compared the action recognition challenge from last year and the different supervision scales of these methods. We note in this case that, for example, the pre-training didn't prove to be, like there are methods really low with a significant amount of pre-training, maybe because Epic Kitchen is egocentric and there isn't a good pre-training data set for it. But the training labels, everything that is 4 is marked above everything that's 3. And in this case, these are methods that use spatiotemporal labels rather than only temporal labels. Through this proposal, we'll be able to understand on the same test set the impact of the amount of supervision we're offering, opening the scale or the scope for adding new training sets, acknowledging they're not directly comparable, but we would understand the direction our community needs to go rather than restricting these training sets. I'd be very keen to hear your opinion on this. Sorry, I'm not attending the panel. If this is of interest, ping me by email or on Twitter. Thank you very much.